Welcome to the Unit 12 Section 5 video on geometric sequences. The NCAA basketball tournament begins with 64 teams after the first 4 games. The single elimination tournament then proceeds until a national champion is crowned. Each round, the number of teams competing is half of that of the previous round. This chart below shows how many teams are playing in each round. So round 1, we have 64 teams, then it's 32 in round 2. Then we go to the Sweet 16, the Elite 8, the Final 4, and then finally 2 teams in the national championship game. This graph shows the information from the table. If the points on the graph were connected, what kind of figure would we have? Well, from our experience in this unit, you can tell that we would have a rapidly decreasing figure, which would represent an exponential decay, because each time we are having the numbers of teams in the tournament through each round. This sequence is a geometric sequence because each team or each term in the sequence can be found by multiplying the previous term by 1/2. The ratio for successive terms, in this case 1/2, is called the common ratio and is symbolized by the variable r. Note that r does not equal 1 because a common ratio of 1 would result in a constant function. So r cannot be 1 in a geometric sequence. A geometric sequence is one in which each term after the first is found by multiplying the previous term by a constant called the common ratio. Any geometric sequence, the common ratio is found by dividing any term by the previous term. So to find a term of a geometric sequence, you're going to take the nth term of an arithmetic sequence with common difference r is a sub n equals a sub n minus 1 times r, where a sub n minus 1 is the term before a sub n. So let's determine whether the sequence appears to be geometric. If so, we're going to find the common ratio in the next 3 terms. So we're going to see if we have a common ratio. So our ratio from 3 to 9, we have to multiply by 3. From 9 to 27, we multiply by 3. And from 27 to 81, we multiply by 3. So the sequence could be geometric with a common ratio of 3, which would make our next 3 terms 243, 729, and 2187 by multiplying the previous term each time by 3. Let's take a look at this sequence. To get from 6 to 10, we would have to multiply by 5/3. From 10 to 15, we would have to multiply by 3/2. And to get from 15 to 21, we'd have to multiply by 7/5. Certainly not a common ratio, so therefore the sequence is not geometric because the first ratios are not common. Like with arithmetic sequences, to find the output a sub n of a geometric sequence, when n is a large number, you need an equation or a function rule. So let's take a look at this pattern. We have our first term is 3, so that would be a sub 1. Our second term would be 6, so that's a sub 2. Our third term would be 12, that's a sub 3. Our fourth term, 24, a sub 4, and so on. So let's say that we have an nth term. We're in the nth position. Our term would be denoted as a sub n. The sequence starts with 3. The common ratio r is 2. You can use the first term in the common ratio to write a rule for finding a sub n. So the first term, 3, is a sub 1. The second term is 3 times 2 to the first, which equals 6, which is a sub 1 times r to the first. Third term is 3 times 2 squared, which is equal to 12. That would be a sub 1 times r squared. The fourth term would be 3 times 2 to the third equals 24. So a sub 1 times r to the third. So our nth term would be 3 times 2 to the n minus 1, which would be a sub n times r to the n minus 1. The pattern in the table shows that to find the nth term, you multiply the first term by the common ratio raised to the power of n minus 1. So a sub n equals a sub n times r to the n minus 1. This is the explicit formula for a geometric sequence. where a sub 1 is the first term and r is your common ratio. So let's do an example. The first term of a geometric sequence is 128 and the common ratio is 0.5. What is the 10th term of the sequence? Well, we're going to use our explicit formula for a geometric sequence, plug in our first term, which is 128, our common ratio, which is 0.5, and we want the 10th term, so that's our n. And we evaluate it to find that a sub 10 is 0.25. For a geometric sequence, a sub 1 equals 8 and r equals 3, let's find the 5th term of this sequence. So we are explicitly told that a sub 1 is 8 and r is 3, and we want the 5th term, so n would be 5. So we plug all those things in. 5 minus 1 gives us the 4th power, and we finish evaluating to get 648. What is the 13th term of the geometric sequence given here? So here we know that a sub 1 is 8. If we want to find the common ratio, we find out what our multiplication factor is by taking a sub 2 and dividing it by a sub 1. So negative 16 divided by 8 gives us negative 2. In other words, we multiply 8 by negative 2 to get negative 16. And negative 16 by negative 2 to get 32. And 32 by negative 2 to get negative 64. So a sub n equals a sub 1 times r to the n minus 1. We plug in our a sub 1, which is 8, which is our first term, our common ratio, which we just found to be negative 2, and we want the 13th term, so that's our n value. Then we simplify and get 32,768. The table shows a car's value for 3 years after it is purchased. The values form a geometric sequence. How much will the car be worth in the 10th year? So here we're talking about how much a car depreciates. So we're going to find the common ratio by doing a sub 2 divided by a sub 1. So that would be 8,000 divided by 10,000, which would give us 0.8. Then we are going to plug in our first term, which is 10,000, our r, which is 0.8, and our n, which is going to be 10, because we want to know the 10th year. Then we simplify and solve to find that the car would be worth about 13, 14, 18. So $1,314.18. So that is what the car is estimated to be worth in the 10th year.
Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.